This, we have the lava flow problem, and we have to find how fast the lava is moving and the distance that it is from the crater. So the original equation is 7 times 2 minus 0.9 to the x power. So to find the derivative of this, you're going to take the product rule. This is going to be 0 times 2 minus 0.9 to the x power plus 7 times negative 0.9 to the x power times the ln of 0.9. Now, the ln of 0.9 comes from the derivative of negative 0.9 to the x power. What we're going to do is the power rule, which you take the ln of negative 0.9 to the x power, and that gets the x ln 0.9. So now we need to find how fast the lava is moving when x equals 0, 1, 5, and 10. So you plug in those numbers into the derivative equation and get at 0, it's 0.75 miles per hour, 0.66 miles per hour at 1. At 5, it's 0.43 miles per hour, and 0.25 at x equals 10 miles per hour. And so this shows that the lava is indeed slowing down as it is moving towards the crater, as x equals the number of hours that have passed.
Okay, so for part B, they want us to find x in terms of y and then take the log of both sides using some appropriate log bases. So first off, in order to do that, we're going to have to divide each side by 7 because we're trying to get x isolated here. So dividing each side by 7, you get y over 7 equals 2 minus 0.9 to the power of x. So you subtract both sides by 2, get rid of one more thing. So now you're going to have y over 7 minus 2 equals negative 0.9 to the x. And so now you're going to be taking the ln of both sides, and this is going to make it so you can get that x out of the exponent. Out of the exponent. So once you're able to get that out of the exponent, you're going to be able to divide both sides by 0.9. So you're going to have negative x equals the ln of the quantity of y over 7 minus 2 over the ln of 0.9. Then you're going to divide that by negative 1. So you're going to take that and multiply it through the top, and you're going to end up getting ln of negative y over 7 plus 2 over the ln of 0.9.
Part C.
Okay, so for this one, you're going to have to take the quotient rule in order to figure this one out. So what you're going to do is you're going to take the derivative of the top times the bottom, and that's going to be 1 over 2 minus y over 7 times the bottom, which is ln of 0.9, minus the top, which is the ln of 2 minus y over 7 times the bottom, which is 1 over 0.9, and that's all over the bottom squared, which is what the quotient rule is. So after that, we're going to get 1 over the ln of 0.9 times the quantity of ln of 2 minus y over 7. And so we're going to have to take the derivative of y over 7 here, and that's just going negative y over 7, which is just going to be negative 1 over 7. So that's going to be 1 over the ln of 9 times 1 over 2 minus y over 7 times negative 1 over 7. And that's going to give us 9.4912 times the quantity of 1 over 14 minus y. So we're just going to multiply that across, and we're going to get 9.4912 over 14 minus y. And part 2 of this problem asks for us to plug 10 into the equation to see what we get for dx dy, the speed. So, and that's just plugging straight up 10 in. So we get 2.3728 hours per minute.
Okay, now on to part D.
All right, so for this one, we go back to the original equation, y equals 7 times the quantity of 2 minus 0.9 to the x, because it wants us to solve for this in terms of x, but we don't have an x. So we're going to have to get it by plugging it into the original equation to get the y that we plug into the derivative equation up here. So we have 7 times 0.2 times 2 times 0.9 to the power of 10, and that's going to equal 11.5593. And so now we have a y, so we're going to be able to plug that into our derivative equation, and that outputs 3.8886 hours per minute.
Okay, now on to part E. Now, part E is asking about the reciprocals for dy over dx and dx and dy. Are they reciprocals? Well, that answer is both yes and no. See, dx over dy when x equals 10 is 3.8887 is a reciprocal, but of the dy dx value at x equals 10, not the dy dx value when y equals 10 value, which would have been what the answer given over in part C was. So dx dy at x equals 10 is a reciprocal, just not of the value given in part C. And that is the VAP.